So we're going to continue with the quadratic equations today. Today we're going to learn 3 other methods of solving quadratic equation. In addition to solving by factoring that we saw before, we have 3 other methods. One is called the square root property, then completing the square, and also the famous quadratic formula. So let's briefly review about by factoring, solving by factoring first. And when you have a question like this, the question will specify what method to use. So you have to use the method that's specified by the question, not just any other method, unless the question does not specify what method to use. So let's first review of solving by factoring. As we saw before, we have something like this. So let's consider this equation here, which is a quadratic equation. What makes this again a quadratic equation? What exactly makes it quadratic and not some other type of equation? Everybody, why do we call this quadratic and not cubic or some other type of equation or first degree?
It has power 2.
Exactly. So power 2 is the highest power. That's what makes it quadratic. If this was 3, it would be cubic or third degree. If it was 1, it would be linear equation and so on. So solve by factoring. So that means we need to factor first, not use any other method of these. So before you factor, this needs to be in standard form, meaning all the terms should be on one side, on the other side should have 0 only. Okay, if you don't have all the terms on one side, so do so first. That's standard form. Ax squared plus bx plus c equals 0. Then factor. Obviously, the method is solved by factoring, so you need to factor this. This is a trinomial. So 2 numbers that multiply to 12 and add up to 7 are positive 4 and positive 3. They multiply to 12, and the 2 numbers add up to 7 here, or b. Once you do that, you use the zero product property. Zero product property, that means a times b equals 0. That means either a equals 0 or b equals 0. So x plus 4 or x plus 3 equals 0. Then you solve these resulting first or linear equations. X is negative 4, and here x is negative 3. So that's the solution set. Solution set of this equation using factoring. Okay. So it's always, again, these 3 steps. Standard form, factor, use the zero product property. So now let's talk a little bit about the square root property. Okay, the square root, another way or method of solving quadratic equations. Let's see how that works. So basically, if you have x to the second, and you have maybe 25 here. So a number squared is 25. What could that number be?
It's going to be 5.
5.
5 or?
Minus 5.
Exactly. If you square 5 or negative 5, both ways you get 25. So that equation is basically, we just solved it. Well, unwittingly or unintentionally, we solved this by using the square root property. Because what you did was, before I write the square, so we have the equation. So basically we wanted the root of this number and this for this number. So what we did was apply the square root to both sides. square root has index 2. The power here is 2. And also here the square root of this. So basically, as we said before in the previous lecture, second power and the square root are opposites of each other. They cancel each other out. If you have one, you can apply the other to cancel both. So this and this cancel out. So you have x. And here we say plus or minus 5. The reason being is because if you square either one of them, you get 25. So whenever you cancel a root or a square root or a power, an even power, every time you cancel an even power, you always have to do that plus minus. Again, we said before that whenever you have x here and you have some index and this, these cancel each other out, you get x. Also, if you have this and the power is outside, either way, the power is here or out over the radical, either way, the radical and the index cancel each other out, you get x. Okay, and in this case here, if the index is even, you do plus minus. Only if the index is even, not both. Okay, so, or at least for the square root, that's the only root we're going to use to solve quadratic equations. So whenever you apply the square root on both sides of the equation, remember there's going to be a plus and a minus, and this is the reason why, because either one will work, not just one. Okay, so that we just solved it using the square root property. We could do the same thing with this method, but this is explicitly done using the square root property. Let's do this quickly with factoring. If the question says by factoring, then you have to use this method. What is the first thing you do again? From this list to solve this by factoring, it would be the standard form. That means we're going to move this over first. It turns into this. If you move over, you change the sign, then factor. This is a binomial, or the difference of two squares. You can say x minus 2 and x, not minus 2 actually, but x minus 5, and x plus 5. Okay, factor, now we're going to use the zero product property. Either this is 0 or this is 0, so x minus 5. 0 or x plus 5 equals 0. Here means x is 5, or x is negative 5. As you can see, we got the same solutions as this. Okay, so here we used the zero product property, but here we used solving by factoring. So again, the question will tell you which one to use. If it says this, then you have to use this method. If it says by factoring, you have to use this method. And you don't get credit if you use the wrong way or the way that's not defined. Okay, so that's another way. As you can see, either way you use any of these four methods, the result will always be exactly the same. It will be consistent. The method will be different, but the solution will be the same. And the reason why we prefer one over the other is because of convenience. Sometimes when it's difficult to factor, we find it easier to use other methods. But if maybe factoring or probably the square root property, maybe these are probably the fastest and easiest, but we need other methods for some special cases we're going to see later, because these two are not always this easy or this convenient. That's why we need other methods. Okay, so that's one method of one way to solve quadratic equation by the square root. And you don't have to do both, only do the method that the question is specifying. There's another one. Let's say we have this plus 9 is 0. So solve again by the square root property. So what do you think you do here in order to solve this using the square root property, not factoring? Or we could actually turn this into a minus. Okay, how do you solve this using the square root property? If it was factoring, we would do this right away, but we need to use this method instead. So what do you think happens now?
So we just take a square root from it, so it's going to be x minus 3, x plus 3.
Before that, before you take the square, are you going to take the square root of the whole thing, or?
No, we're gonna take a square of the 9.
So,
Right.
okay, so before you take the square, we need to get the square by itself. Okay, so we can't take it right now, or the whole thing. So we're gonna need to first move this over. So before we use the square root property, the square has to be by itself. So we're gonna move the 9 over, and it turns positive.
It's going to be x equals to 9, so x equals to 3. Or
Okay.
minus 3.
Or minus 3. All right, so once you get the root by itself, make sure it's by itself without a number here, or after, or anything.
Do we put in a module?
What do you
Because
mean?
we, I mean, you know, the 2 lines crossing in the beginning and the end of the number, because if we are going to use the minus in the equal side, like, let me write in the chat. So like,
Okay.
like this, because we are going to use also the minus 3 and plus 3.
Oh, the absolute value.
Yeah.
Well, in that case, we want to. In this case, we need to find both solutions.
So it's absolute. We have to find the absolute value, right?
If you do the absolute value, it will give you one solution only. It only gives you the positive solution. But in this case, we want to have both. So we want to find all the possible solutions. So we have to write them. In certain cases where you only need, when you're only interested in the positive value, that's when you apply the absolute value. Okay, so in certain cases, sometimes you just want to see give me the cells or whatever, the increase that was positive or something like that. So you only get the positive value. But in this case, we need to get both. So again, once you isolate the square root, then to cancel you isolate the square. So the opposite of the square is the square root. So we're going to apply the square root of the same index as this to here, and also here, index 2. So now again, square root and the second power of the square cancel each other out, get x by itself. But again, whenever you use a square root, it's not just 3. Don't forget to put plus and minus. So the square root of this is plus minus 3. Because either one of these, if you plug 3, you get 9. Also, if you plug negative 3, you get 9. So we need to get both solutions. So that's the solution here. Okay, so it's very simple. The square root property, it just means apply the square root to both sides. But before you do that, make sure you isolate your square before you can cancel it using this formula. Isolate it first. Sometimes it might not be isolated. For instance, if you have 2x to the second minus 32 equals 0, or 32 is fine. So now, again, we want to solve this using the square root property. What do you think we need to do first?
We have to guess what's square root of 32. Oh wait, my bad. We just have to move the 32 on the equal side, so it's 2x in square equals to 32.
That's right. So the first step is to move the 32. That's what we call isolate the square. So we're going to isolate the square or the second power. So to isolate it, we're going to cancel this first. So it's going to add 23 to both sides, or 32 rather, to both sides. So 2x to the second, please cancel out. Is the square by itself yet? Is the square by itself on this side?
No, it's not.
No.
Okay, so we need to cancel these two.
So we can divide 32 to 2. So it's going to be x squared 2 equals to 16.
That's right. So we're going to divide both sides and always isolate the square root before you apply, isolate the root before you apply the square root. So here this is 16. Finally, we can now, so once you isolate it, next step is to apply the square. Apply the square to both sides. And don't forget the plus minus. Whenever it's a square root that you apply, or any even root, any index that's even, you need to put that plus and the minus. Okay, so let's rewrite the equation here. So again, if this was by factoring, we would move everything to one side, factor and solve, but this is the opposite. We need to isolate this. Now we're going to apply the square root, same index as the power. These cancel each other out. Also apply the same thing, the square root to the other side. X, what is x equal to?
4 or minus 4.
Right, plus minus 4. Okay, that's important. So we need both solutions, not just one. Again, the reason why you put plus minus, as you can see now, if you apply or if you plug either 4 or negative 4, you get 16. You can also apply, check that here in the first equation, and you'll see that it works. We don't need that with index like this. We don't need index when we have a different power than 2. For example, here, what kind of square are we going to apply here? Not square, what kind of radical? What index?
2.
No, we have 3 here, so the index should be also
3.
3. When you do that on the other side, you get 3. So when you solve, these two cancel out, you get x is, what is the cube of 8?
2, yeah?
2. That's it.
Yeah, I meant before that, so that's why I said.
Oh, okay, so this is the only number, the solution. You don't need plus and minus. X to the second or x to the third is 8. If you check 2, in fact, 2 to the third is 8. But there's no minus. If you put minus here, what do you get? If you put negative 2 to the third, what is it equal to? It will be negative 8. And that's not what we want. We want 8. So our equation was this. X to the second or the third is 8. So if you plug 2, you get 8. You can't plug another number and get 8. If you plug negative 2, you will get negative 8. That's not what we want. We want this. So that's the reason why we put plus and minus. Okay, only when the power here and the index are even, the same and even. In case you were wondering, so this does not require plus minus because the index, the power are odd. But here we do have that because the index and power are even, and you can check for yourself. If you plug x here, you get plug 4, you get 16. If you plug negative 4, also get 16. That's the reason why we have 2 solutions. That's pretty much it, how you solve an equation using the square root property. Again, isolate your square root. It could be already isolated or it might not be. It's pretty simple. All you have to do is apply the square root on both sides and you get your solutions. You may also have, still one more example here. Let's say you have x plus 1. The second power, and here maybe, let's say 4. Okay, so we have a square root here. It's already here by itself. That's good. So now we want to cancel it. What do you do to cancel this second power, this square?
I'm sorry, what was the question?
We want to cancel this square.
Okay.
Same way we've done before. So how do you cancel? So the square is already isolated. So this whole thing is raised to the second
So
power.
it's x2 plus 2 equals 4. You mean that, or?
We want to cancel this one. So first thing you isolate. Second thing you apply the square to both sides. So this will turn into what? Let me write it again. So again, the purpose is to cancel this second power. So to cancel it, we're just going to apply the square again. Square and square root cancel each other out. Also use the same thing here, square. Now if we cancel the square root and the square, what is left inside?
It's x minus plus 1 equals to 2.
That's right, x plus 1 equals, but not to 2 again. When you take the square root of this,
Isn't it
index,
2 or minus 2?
that's right, would be plus or minus 2. That's very important. So every time you apply the square root to cancel the square, what's inside is what's left, but it's got to be plus and minus. So here, the x is not by itself yet. So we're going to split this into two equations.
So x either is a plus 3 or a negative 1.
That's right.
No, wait.
So x plus 1 equals 2.
Oh, 2,
or
yeah.
x plus 1 equals negative 2. So we have two solutions. Because the x here is not by itself yet, we have to solve further. Unlike here, once you cancel the square root, you end up with x by itself. So no need to turn this into two equations. That's basically the solution. But here we have to, because we need to find a solution. So here, if you subtract 1 from both sides, you get x1. If you subtract 1, you get negative 3. Okay, again, the key thing here is when you solve using the square root property, you want to cancel this one by applying the square root. And before you do that, be sure it's isolated by itself on one side. Then you apply the square root to both sides. So always 2 and this cancel out, or any other index and power. If they're the same here, you cancel each other out because of this rule that we saw last time. This if n is even. So plus minus only if n, if this number is even, we need plus minus. If this one is odd, for example, 3 and 3, 5 and 5, no need for a plus or minus, just the plus. Just one solution. The whatever the root is, could be plus, we put minus. Okay, so that's the one method. Now we're going to move on to the next method of solving equations, and this one is called completing the square. That's basically when you don't have a square, we don't have a perfect square, and we need to find one. Let's see what that section is. So if you look, let me see, if we look at these examples, let me find a simple example here for this here. So far we had no problem with finding a square or getting a square by itself. Here we had a square by itself, which is good. Here we just had to move this, and here it was already by itself. So we have a square by itself and then 4. Here it wasn't by itself, but we had to do a couple of steps to isolate it. But sometimes we may have a difficult situation where we don't have a square or a perfect square by itself. So we have to do something in order to turn the equation into maybe something like this or like this. So this is what we call completing the square. Completing the square. So let's take a simple example, but instead of doing it the easy way by factoring, okay, so if you look at this equation here, we can easily solve it by factoring it. The solutions are -2 and -3, no big deal, okay? But let's try to use the completing the square method. Let's assume that we don't know factoring yet. And we want to solve this using the, well, actually, we're going to need factoring, but you just use this simple example. I didn't want to use complex numbers or numbers with radicals yet, but we already know that the solutions are -3 and -2 if you factor. Let's dance around a little bit and try to find the solutions using this method, which is a little bit longer, involves more steps, but the point is to learn those steps, because sometimes when you can't factor here, this comes in handy. Okay, so let's assume now we don't know the solution to this, so we're going to use completing the square. So here's how it works. When you have, this is the standard form. This is the standard form of quadratic equations. So there are three main steps here. So to complete the square, basically, so let's say we want to solve this by the square root property. It means we want to apply the square root to both sides. But we can't, because even if you isolate this one, if you move these two over and isolate this, you can't apply the square root right away, because you're going to have x here and you're going to have x here, and that's not good. Here we didn't have a problem because x was by itself with no other x here. If you try to complete this, use the square root property right now, and you decide, for example, to move these over first and apply the square root, it's not going to work, because you're going to have x here and here. So that's the reason why we have to work around this and try to turn it into something like this, or like this. A square by itself and only a number on the other side. A square by itself, only a number on the other side. That is basically the purpose of completing the square. We need a perfect square like this to apply the square root to, just like here. So first you want to move c to the other side. Okay, move c. There's the three main steps here. Move c to one side or to the other side. Okay, c has to be by itself. Once you move that c, then you're going to add this, add a number. You're going to add b over to the second. Going to add whatever this number might be. You find it based on b. In this example, it's 5. So we take that number b, divide by 2, and raise it to the second power. You add it to both sides. Again, all this work is just to get it to look something like this, where we can apply the square roots of both sides. And then you factor, you will have, once you factor, you have a square. Okay, once you factor the result of this, you will end up with a second power like this. And finally, apply the square root. Square root to both sides. So this is basically what we mean by completing the square. These 4 steps. And these steps will later be summarized in one formula, which we know, or the famous quadratic formula, if you know it from high school. If not, you're going to learn it today. So it's either completing the square, or if you want to summarize all those steps into one, we're going to turn that into one formula, all these steps together. Okay, let me use actually a different example here. To make things convenient for the fractions, I'm going to use maybe, let's use this instead. Actually, let's use 4 and 4. We already know the answer to this easily with factoring. It will be +2 and +2. If you do factoring, you can do that easily. You can find that easily. But again, let's pretend we don't know factoring. We don't know this yet. It's basically, again, just dance around this problem and get back to these solutions. So let's follow this step by step, this square root property, or completing the square. So the first thing is, what is the first thing according to this? So let's solve that, not by factoring, but using the square root property. What is the first thing you do again to this equation from this list? Tell me specifically what happens. Steps are here. Just tell me exactly what happens.
Oh, we're on x plus. Oh, okay. So, at first we can move the 4 to the equal side, so it's going to be x. Oh no, that's a no. We don't use that.
That's it. That's good.
Or yeah, we can use it. So it's going to be x in square plus 4x equals to minus 4.
We're gonna move this completely over. That's right. That's what this first step is.
Yeah.
The equation, once it's in standard form, we move c to the other side.
Yes.
Again, the reason why we need to do that, because right now, if we try to isolate the square, to apply the square to it like this, it won't be possible because we're gonna end up with x on the other side. That's why we're gonna have to make a perfect square out of this, something that looks something like this. To do so, we're gonna follow this step. So move c over, so x to the second plus 4x, and positive 4 turns into negative 4. We're just gonna follow this step by step here. What happens next? We need to add this number to both sides. First, we're gonna find this number. It's b by 2. What is b? B is the number, right? B is the number that's next to the x. In this case is
4.
4. So we're gonna take that. So b, so it's gonna be 4 over 2 to the second, which is 4.
Yes, it's because it's 2. 2 times 2 is 4.
That's right. So we're gonna add that. So after this step, we're gonna add that to both sides. Because it's an equation, you can do whatever you want on both sides. Add this number here to both sides. Also here.
Yes.
All right, so we did this one. Now we're gonna factor to get the square. Let's factor this. Okay, we're gonna factor this trinomial and turn it into a square. This is 0 here. Now we need two numbers that multiply to 4 and add up to 2. Those numbers are
4 to 1 and 2 to 2. So we have to use the, I believe it was the lowest, right?
no, two numbers are multiplied to 4. Same numbers add up to 4. The numbers are
2.
2 and 2.
Yeah.
This whole thing here is just to have something times itself. So factor to get this square.
Yeah.
Now, when you times something by itself, for example, a times a. What is a times a?
A in square.
Squared, that's right. Same thing here, we have something times itself. That means it's that thing squared. That thing squared. So plus 2 plus 2 I mean, just 1. So this times itself means that to the second power. So that's the important thing here. We needed this second power, and we have 0. So now it kind of looks like this. You have a perfect square and a number on the other side, not x. If we had x here or something, it wouldn't be possible to take the square. We would require some more work. Okay, so now we can do the last step here. So we can apply the square root to both sides. Apply the square root. So at this stage, it looks almost identical to this problem here. You can go ahead and take the square root of both sides. So let me rewrite it again. So it's time to cancel the square by applying the square root. Also on the other side. So now what is left on this side if we cancel these? with x plus 2. The square root of 0 is just 0. So we don't need that plus minus 0 because 0 is a neutral number. It doesn't have a sign. So we're just going to put 0. And if you solve this, you get negative 2. So basically, we just got back to, it's actually negative, not positive. Because when you factor, it will be x plus 2, x plus 2. That means x plus 2 is 0 or x plus 2 is 0 will be the same solution, negative 2. With factoring, this would have been much faster and easier. But we try to do the same thing just to show the steps. Unfortunately, the numbers are not always this convenient like this to make this simple. If the numbers are this easy and convenient, we can jump right ahead and do and use factoring. But we didn't have to do all this just to find these two solutions, but we just wanted to learn the steps with some easy numbers without radicals. Now let's take an example where factoring is not convenient, where you can't factor. We'll see how to use this method basically of the square root to solve the equation. Okay, again, factoring is not always possible. Let's do one example when we can't factor right away. Otherwise, it would have been the easiest way, the fastest way. Okay, the example here would be, okay, let's do, so this is where it's gonna make more sense now. So if you have x to the second, let's say x plus 10. Again, we always try to be efficient and convenient. We try to use the easiest methods. If this was by factoring, we would do it right away. Can you factor this? Can you find two numbers that multiply to 10 and add up to 8? So it won't be possible to find those numbers, at least integers. You won't be able to find those. No two numbers multiply to positive 10. I mean integers and add up to 8. Only 5 and 2 multiply to 10, and 10 and 1. And you can't get 8 from 5 and 2 or 10 and 1. So now that's where this becomes convenient, and we have something to work with, even though we can't factor. So this is where completing the square will work. Okay, so let's do this. So even though you don't see the two numbers that multiply to 10 and 8, they do exist, but it's just not convenient, not in integers or whole numbers. So let's repeat the same process here and solve this even though we can't factor. Okay, let's do this fast. What is the first step again? These are your steps of completing the square. Okay, so what happens first? Everybody in the room?
We are in the below or here?
In this example. So we want to solve
we do this,
completing the square.
Move to one side.
So we do the same.
Okay, so 8 plus 8. Again, we only move in the 10 because
Minus 10.
And what do we add to both sides? B to the second over 2. This is B divided by 2.
Over
right.
10.
8 by 2 first will be 4 and square it. Take B divided by 2 and square it. Will be 16. So 4 more 8 squared. So it would be 4 to the second, which is 16. Right? So let's add that 16 to both sides. What happens next? We can factor this now. We for sure can have a square from here. So what is this multiply to? Two numbers are multiplied to 16 and add up to 8.
Numbers
Only not 6 and 2.
4 and 4.
That's right, both 4 and 4.
But 4 times 4 is 16, right? But yeah. Wait.
Right. So the whole purpose of completing square is so we can get something times itself. This is what turns into a square, as we did here. And of course, we can simplify this. That would be 6. Okay, and okay, we did that. Factor to get the square, so we're gonna get the square from here. So many times itself means that thing squared and 6. At this point, now we have a perfect square by itself. Only a number on the other side. We don't have x here. So again, we're back to something like this. Okay, so that's the list. We did this. We factored. What is the final step here to solve this?
It's wait.
X plus 4. X plus 4 equals 0. No.
Oh, we have to just do the same thing. We just gonna take the square from this and the 6 too.
Yes.
So it's going to be x plus 4 equals to 2 squared 3.
Already did.
That's right. So again, this method is completing the square. So once you find the square, you don't want to go back again and factor. You don't want to solve by factoring. This is solving by completing the square. So we have to go through these steps. At this point, once you isolate, you get your square by itself. You want to cancel it by applying the square root to both sides. Okay, exactly as we did earlier here. And now, what is left here?
X plus 4. 2 and 2.
X plus 4 equals, and here
6. Yeah.
So again, what about the signs here? So we have square root of 6, which is
plus minus. I mean negative, positive 6.
Exactly. So we have to have plus minus and the square root of 6. It's not a whole number. It's not an integer. It's a decimal. It's okay if it's left like that. Now we're not done yet. We need to get the x by itself. So what happens next?
X
to plus minus. Yeah, she can finish. My bad. Sorry.
No. It's, I mean x equal minus 4 plus 6.
X plus 4 equals
minus 4 plus 6. So it's gonna be
radical. One with radical, positive radical 6, and the other one with. What's the other one? So one with positive.
Negative.
That's right. The other one is negative 6. Negative radical 6. And then we add or subtract 4 actually. X is, so we cancel these. X is radical
2. Why? I don't understand.
No, you can't do that. This is radical 6. This doesn't have a radical. So
okay.
Radical,
so it's gonna be like this, yeah?
Exactly. Will not change. It's gonna be like this. And same thing here. If you subtract 4, x is negative radical 6 minus 4. And that stays like this. So you don't have, there's nothing else you can do here. This is a decimal. You may turn this into a decimal number if you want, but that's about it. So as you can see, even though we couldn't factor, we couldn't find two numbers that multiply to 10 and add up to 8, but we were still able to make a square out of this square before we applied the square root to it. So that's completing the square. So completing the square, basically, you don't have a square ready yet, and you can't use factoring. So that's when you have to do this. So usually these are used in an order of priority or convenience. Usually probably factoring would be the fastest one, and maybe the square root. But if you don't have, if none of those can work right away, so you need other ways. You need other ways. For example, completing the square. That's one of them. And if you thought this was a lot of work and too many steps, well, that's where the quadratic formula comes in handy, because it basically summarizes all these steps into one formula. Okay, can anybody remind us what the quadratic formula is? What's the quadratic formula? Sure, all of you.
It's minus, I believe it was minus a plus, oh no, minus b plus minus b2 minus 4ac in a square and divided by 2a's.
That's right. Are you looking at it?
I'm sorry, what?
Are you looking at it somewhere, or this is the top of your head?
I mean, it was, I learned it in the 10th grade or 9th grade.
Right. Okay, that's good. So this is exactly the formula here. There's a 4 missing here.
Wasn't it 4ac? Yeah.
For AC, yeah. Okay, so basically,
Professor, I'm sorry. Can you scroll it up a little bit? I'm gonna.
like this.
Just one second. Thank you.
All right. So
Yeah, it's good. Thank you.
all right. So now, so again, we have factoring, which is probably easy if you can factor right away. You use it to solve quadratic equations. You have the square root. If you have the root, square root ready or ready to be isolated. If that doesn't work, then you may need to complete your own square, completing the square using these steps. It's not too difficult, just remember those steps. You just work your way through it. And finally, we have the quadratic formula. So all these methods are used to solve quadratic equations. Depending on the situation, one can be more convenient than the other, but in the exam, you gotta follow the exact rule that the method that the question is asking you to use. Unless the question does not specify, as I said before, then you're free to use either method. But if not, you have to use the method that's determined by the question. And if you use other method, basically that's not a solution. You don't get credit for using the wrong method or the one that's different from the question. All right, so let's basically see how this was a few steps. Let's try to solve the same one again, but instead of going through all this, let's just basically use this one here. Use the formula right away. So we should be able to get, if our math is correct, we should be able to get the same solutions here, and we will do that. So assuming here we didn't make a mistake, everything looks good. So let's use that quadratic formula and get the exact same solutions. Okay, so as I said before, the standard form of quadratic equations is always this. Okay, so these numbers that you see here, A, B, C, there's 3 variables here, A, B, C, those basically come from here. Any quadratic equation has these 3. Whether you see them or not, they are there. First thing you want to do is get these values, A, B, C, and carefully get them without, missing a sign or getting this wrong number. So let's apply that to the same equation and see how to get the exact same solutions without going through all those steps. Basically, this formula kind of summarizes for us all this work. All we have to do is take A, B, C and plug them into this, and it does the job for us. Again, use the same one here, x to the second plus 8x plus 10 equals 0. So let's get A, B, C. What's A, B, and C of this equation? What is the coefficient of this? So A, again, is always next to x to the second. What is A here?
A is here x squared.
No, A, the coefficient of x to the second. A times x to the second.
Oh, 1.
That's right, it's an invisible 1. Then
8.
B is next to the x, it's positive 8. Finally, C is the last number.
10.
10. That's your first step. You want to get A, B, C from your equation. And then you just plug them. That's all you have to do. Just plug these carefully into this and simplify. So first get these. Plug into formula. And simplify again. You got to be careful when you simplify these. So plug into a formula and simplify, meaning all these 3 will go into the formula. So these 3 here we'll go into this. So here's what you do. Again, the formula will be given to you. So in case you have a hard time remembering it, it will be given to you in the exam. We just have to use it properly. So there's always going to be this minus here. And then you follow it by the value of b. Could be b could be negative, could be positive. This ought to be always this minus, and maybe another minus from here. So here's what you do. Take that minus. I just put some empty parentheses for b. Then plug whatever b is. Could be a negative number, could be a positive. You may end up with a double negative, which turns into a positive. Plus minus. Write your variable, and then again, leave some empty parentheses for the value of b, whatever b might be. Don't forget the power. And complete your square. These are inside the square. Okay, do not make the mistake of stopping the square here. These negative 4ac are inside the square. Again, put 4. This means 4 times a times 6. You want to put 4, put some parentheses, 1 for a, 1 for c. We're going to plug a and c later into them.
Professor, as I remember, we can just remove the squares. We can just cancel the square, right, with that formula. Which
for this one?
Yeah, we can use b minus 4ac.
We'll get into that. That will be, if you want to just start with this one and try it first. You want to try that first? We'll get into that. I'll show you how to check this first before you do the whole thing. Okay, so again, when you plug, make sure put some empty parentheses for ABC, and make sure you extend this all over, all the way to the end, not just over here. Okay, all this is inside the radical. We're gonna get into this. This is called delta. This value here, we call it delta like this. We're gonna get into it later, a little later. So another common mistake is the fraction. Most people, not most people, but some people like to start it here. It's actually, the whole thing is over 2, and again, a, 2 times a, leave empty parentheses for a. That's how your setup should be. It's very important that you get every sign here right, because the sign matters a lot. You'll see why later when we talk about delta. Okay, so the formula will be given to you. First, just put some empty parentheses for ABC. Then extract your ABC from the equation very carefully. Make sure first it's in standard form. Okay, before you do this, before you get ABC, if let's say this negative 10 was here, negative 10, we'll move it over to make it positive 10, but make sure it's all in standard form first. You can add that step here, so standard form. Then get ABC, plug that into this. So what is B? B is here is 8.
Professor, you're saying so instead of 0, it can be, for example, 4. And
yes.
First we just move all like numbers to the left side and then just equal 0, yeah?
Exactly. So before you use the quadratic formula, move all the terms to one side. For example, if you have this, minus x plus 5. So before you get ABC, you gotta move these over. Only get ABC when the equation is in standard form like this, all on one side, and then plug them. So back to this. So we have B again inside, minus 4 times A times A, as we said, is 1. C is 10. Finally, A again here is 1. Every sign matters here. If you get one sign wrong, the whole thing could be wrong. Again, be careful. Sometimes you may have a double negative here. If this B happens to be negative, for example, here minus 8, you would have another negative, which turns into a positive. But in this case, it stays like that. So negative 8. And after plugging, what you want to do next is you want to simplify this very carefully. Start with, so we're going to use the order of operations, or PEMDAS, if you're familiar with it. So we start with the exponent, which is 64 here. Then what you do is multiply these two first, and whatever you get, multiply by the third one. So negative 4 times 1 is
negative 40.
Negative 40, that's right, negative 4 times 10 is negative 40. Again, make sure this extends here over 2. Back to the inside, what is 64 minus 40?
24.
24 over 2. At this point, we're pretty much done. That's the solution. Or you may wonder, wow, it doesn't look exactly like this. What do you think? Is it wrong, or is there something else we can do to make it look like this?
No, it won't be wrong.
So, say it again, it's not wrong?
I believe it's not.
It's not
I
wrong.
mean, we can, scratch them into lower
Yeah.
numbers, but I believe it's gonna be the same.
Right, it's gonna be the same, that's right. So let's simplify this. This should look like that. At this point, this is good enough. You don't have to do anything else, that's all right. But since we got these solutions here in this form, let's prove that this is exactly the same as these two. We're just gonna do a little bit of factoring and some basic radical simplification as we did the other day. So that's the reason why we learned radicals, so we can use them here, especially with quadratic equations. First, so basically we're gonna apply all the rules of addition, subtraction, multiplication, division we learned about radicals 2 classes ago. First of all, we don't know the square root of 24. We wish, if we were lucky, this would have been 25. There are cases where you can get perfect radical here or perfect root. But we can turn this into some numbers, right? 24 and 24, we can write it as 2 radicals.
Like 4 and 6.
That's right, we can use 4 and 6. Why? Because this can be simplified, this will stay. And it's better than 8 and 3. 8 and 3 will not give us any perfect roots. Over 2. So there's going to be negative 8 plus minus. So radical 4, or the square root of 4 is 2. And we have radical 6, which stays inside. You can't simplify it. You can turn it into 2 times 3, but none of those has a perfect radical, so it stays like that, 2. Finally, this is with, or before that actually, one more step. We can actually cancel these 2. We have a 2 here, we can get a 2 from here, we have these 2. So let's factor 2 out from these 2. We're gonna factor 2 out. Once we get the 2 out, we can cancel it out against this one. So the common factor between these 2 is 2. If you divide this by 2, you get, if you move 2 out, this will turn into negative. If you take 2 out of this, factor to the outside, or divide by 2, what do you get?
You get, wait.
Remember factoring, like we did 2x
Yeah.
plus whatever, 8, for example. If you factor 2 out, what do you get? Divide by 2x plus
2 times 4.
x plus 4.
Yeah.
Because 2 is a common factor, we move it to the front. Same thing.
So you just use 4 here.
Negative 4.
Yes, plus minus.
Right.
Say, in the square root 6.
Right, radical 6, because this 2 canceled out. We moved it to the front. So we moved 2 from here to the front. And the reason we did that is to simplify. This is like simplifying polynomials or rational expressions. Now we can cancel that out. So the solution here is negative 4 plus minus 16. But we can turn that into 2 solutions. So we can write one solution with a plus. We can call that x1. So one solution with positive radical 6. And the other solution with a negative. Again, we understand why we have the negative and positive. So x2 is negative 4, this time minus 6. Okay, so that's basically how the quadratic formula works. We just plug ABC into the formula. As you can see, this is exactly where we got earlier. Okay, we got the exact same solutions. But earlier we didn't use the formula, we used basically the steps that led to the formula. So instead of repeating all these steps every time, we kind of summarized them here in one quadratic formula. So now we can understand why do we have the plus and minus. We understand the whole thing first because of these steps. We proved them, we demonstrate how they work. Now we can guess why we have plus and minus in the formula. Because of, again, when we take the square root of a number, we have a plus and a minus because Like we said here, either 5 or negative 5 will turn into 25. If you square 5, you get 25. If you square negative 5, you get 25. So that's the reason why we have this plus and minus. So basically, we went through steps like these in order to come up with this formula. It didn't come out of nowhere. So here we use the actual steps. We got these solutions. But with this one, we kind of summarize them. So if we work with this, if you move c to the other side and divide and add b over 2 to the second or something, you will end up with this formula. And that's the quadratic formula, and that's how to use it. All these we learned about radicals for this reason. As I told you before, I told you that we were going to use them in solving quadratic equations and other things. So you should be familiar with all this stuff. We're almost done here. Before we recap, there is one other thing. So this formula itself, if you want to save a lot of time, sometimes the equations don't have solutions. Sometimes we're going to do an example of that actually. Sometimes equations don't have solutions. So instead of using this whole formula from the beginning, we may try this. This gives you an idea whether you can have two solutions or none or one. This little thing inside the radical. This is what we call the determinant. I believe the determinant. Let me see what exactly it's called. The symbol is delta, and it's called the determinant because we use it to determine whether we have solutions and how many solutions we have. You probably have heard of it before. So the determinant and the symbol for that is delta, and that is equal to basically what's inside the radical, only the inside for without the radical, so b squared minus 4ac. You can start with this first and evaluate it. Based on its sign, you would know whether you'll have solutions or not. So here's the deal here. So if delta is greater than 0, how many solutions do you think we have? Everybody remembers this from prior. So if you evaluate this and it turns out to be 0, then you will have two solutions like this. Then you work your way through getting those solutions. If delta turns out to be negative, meaning less than 0, then you have no solution. And finally, if you evaluate a delta and it turns out to be 0, then you have one solution, exactly one solution. And that solution is basically, if this is 0, right? If you cancel this radical, what's left from this equation or this formula? If you cancel this out, if this is 0, then it's removed. What is left in this equation? Everybody?
If we remove 0.
Now, if this cancels out, so the whole radical is 0, it's gone. These two signs also are gone. So what is left in this formula?
Minus b
Minus.
divided by
That's right. That's minus b over 2a. That's it. That's it. That's very easy to find. So there's one solution. That solution is x, just x, not x1 and 2, negative b over 2a. And again, you know where to get negative b and 2a. You get them from your equation. So this is B, this is A. So if delta is 0, the equation becomes a lot shorter. You can do it right away. If delta is less than 0, no solution. So you stop here. You don't have to do anything else. That's it. But make sure you get that right. You got the sign right. That's why I said be very careful with your signs when you plug and get the values A, B, C. And if you have two solutions, if delta is 0, then you have two solutions. So basically you do this. You do what we just did, just work normally with the entire equation. So this can save you a lot of time if you try it first. You can avoid doing a lot of work like this to end up with something that's not a solution. Let me give you one last example here and see another example. So let's say 2x and maybe 2x squared plus x maybe something like this. Or maybe not a minus, probably a plus. Okay, that's an equation. Now let's solve this using the quadratic formula, which is again given. This is in front of you in the exam. So what is the first thing you do again to solve this using the quadratic formula? Or actually, let's put this 7 over here. Let's say this 7 was here. What do you do first in order to?
We're gonna move.
That's right. Standard form, we gotta move all to one side. So we're gonna move this over. So x to the second plus x.
X plus 7
That's right. 0. So that's the first thing. So we'll move all to one side now. We're gonna get A, B, C. Look closely here. What is A? What's
2.
B? Let's see. So A is always next to this. That's 2. What is B here?
1.
That's right. B is next to the x.
X.
An invisible one. Or if it's a negative here, it would be a negative 1. So this is 1. And C, of course, is 7. So since it's about the quadratic formula, so it's better to try this first. Always try this value of this determinant, which determines whether we will have, determines whether or how many solutions we'll have. So try delta here. So delta is b squared minus 4 times a times c. So b squared minus 4 times a times c. What is b again? B is 1. And negative 4 times a, which is 2. And c is 7. Evaluate your delta. Based on that, you may save time, or you may at least know that you need to continue minus. So again, use the order of operations. This is actually second power here. So 1 to the second power is 1. Negative 4 times 2, that's 8, times 7 would be. Make sure you get the sign right here. The signs are very important, as I mentioned before. 8 times 7 is, okay, the sign is negative. So negative 4 times 2, that's 8. 8 times 7, 56. And what is this equal to, finally? 1 take away 56.
Minus 55.
That's right, it's a negative number. It's a negative number. So what do you say based on these? Delta is negative, meaning it's less than 0, so?
There is no solution.
Exactly, so this saved us time. So no need now to use the entire formula because we tried it. That's the usefulness of this. So we didn't, so basically, even if you continue working using the formula, you're going to be chasing something that doesn't exist. So this is not, this has no solution. Again, because of the sign of delta. And the reason being is, if you remember when we said an index of a number here, if you have, let's say, negative 8 or negative 56 itself, And if the index is even, for example, 2, this cannot be negative. Okay, this cannot be negative. This will be undefined. You guys remember that from the first class about radicals? If the index is even, you cannot have a negative here. For example, -9, the square root. What is the square root of -9? In other words, is there a number that you multiply by itself to get -9? Everybody, what is the square root of -9?
It's gonna be 3.
3.
-9.
-3.
What number do you multiply by itself to get a negative? Or can you get a negative from multiplying a number by itself?
No, we're gonna get positive.
That's right. This cannot be negative. This is undefined. And that's the reason why when we get to this point, basically this is not a real number. Radical -56. If you put a -56 under the radical here, this is delta. We don't know how to deal with that in real numbers. Maybe with complex numbers we can find ways, but with real numbers, that's undefined. So you stop here. That's why we try this first. Okay, so it's strongly recommended that before using the quadratic formula, try this first. Try this inside first, because you know for a fact it can't be negative. If you end up with a negative here, we know the index is invisible as 2. There's no way to continue, just say no solution. This took just this much to solve, and there's no solution. So you don't have to go through all this all the way to the end to figure out or to find out that there's no solution. Okay, so that's about it. I know this was a lot of stuff, a lot of solving. But again, one of them implicates the other, so it's not too bad. Let me just recap what we did here. We learned before, a few classes ago, how to solve by factoring, which is this. Just factor, use the square root formula, use the zero product formula. If the question says use the square root property, then isolate that square root if it's not already isolated, and use the square root property on both sides. You may have to move something, you may have to cancel things to isolate it. That's the second method. So factoring, we have the square root property. Then completing the square. That's when we don't have the square, we don't have a perfect square like this or like this, so we have to make your own. Another reason also why we use the completing the square property is because maybe we couldn't factor. Maybe this one was easy to factor, but this one is not as easy. This one here. So if you have a square root by itself, isolated, that's good. If you don't have one, then you can make your own, completing the square of these steps. And all these steps are summarized here in the quadratic formula. So again, the question will tell you which method to use. So you should be familiar with all of them. Factoring, square root, completing the square, and the quadratic formula. Basically these again. And use the appropriate one as indicated by the question. If the question does not indicate which one to use, you're free to jump on any one of these methods. Depending on the equation, really, each one can be, depending on the format of the equation, one of these methods can be more convenient and easier to use than the other. Okay, so that's about it for this lecture. You know, it was a little long. I strongly recommend that you rewatch the whole thing again. Take notes of anything you don't understand and let me know. Email me or let me know by our next class.